I'm Andrew Smith, and this is my Lab 1 video report for constant velocity motion. For the lab, I took a video of a rolling ball and modeled its motion based off of Newton's second law using Tracker and Python. First, I imported the video into Tracker to analyze its motion. I began looking at the video after the ball had started rolling, and stopped recording before the ball stopped rolling. In the first frame, I set the origin of my axes at the center of the ball, and shifted the axes around so that the ball was moving in the positive x direction instead of the negative x direction. I set the origin close to the center of the ball. I used the calibration stick to set the length of the ball for the video at 0.24 meters. The time between frames was about 1/35 of a second, and the portion of the video analyzed is about half a second. Now here's a clip of my video. To predict the motion of the ball, I needed the mass of the ball, which was found to be 80 grams. I found the initial position using the graph of the data in Tracker. The initial velocity was found by taking the total change in x over the time. The velocity was found to be 1.88 meters per second. Finally, I set delta t as 0.1 so that it was small compared to the time elapsed in the video. I started the model at time t equals 0 and ran it to t equals 0.5 using Newton's second law. The velocity was predicted using the formula v final is equal to v initial plus f net over m times delta t. Since the velocity was constant, we can say that f net is equal to 0, therefore eliminating the second term of the equation. This makes the velocity equation v final is equal to v initial. The best way to compare the two models is to graph the results of the two models in Excel on the same graph. The blue dots are the computational model, and the red dots are the Tracker model. While the two do not line up immediately, they do end up matching up in the end, proving that the video and the computational model match up well. The what-if question deals with what would happen if we were to choose a different origin point for the model. Choosing a different origin point in Tracker would have given a different starting position. This would not have affected anything in the model, however, since velocity is the change in x over the change in t, and the change in x would still be the same. The what does it mean question asks if it is possible to measure all of the pushes and pulls that make up the fact that f net is equal to 0. It is not possible to do this as our model ignores some forces such as friction. Therefore, we cannot accurately calculate what makes up f net.